And today we're going to discuss how to um, use type inferencing to basically write less code. So we're going to create global functions that can apply to multiple objects, and we're going to be using the type system in UPBGE, so you don't have to you don't have to import every object you need to use. So I'm going to go ahead and close out the documentation here. Fix some space, bring down my terminal output. All right, and then I'm going to create the Py file. We'll do import BGE, and we'll go ahead and save this file. So in Helix or Vim, it's column right, and then we're going to do tutorial 19.1, and we're going to call this not types. We'll call it types ex for types experiment, I guess, and then .py. And we'll do enter to save it, and now it's a Python file, and we got our coloring now, and the linter's working. It's telling us what we're doing wrong. Awesome. Okay. So we're not going to create components yet. Well, actually, we'll go ahead and create a component to be our main. So we're actually going to create a component called main that's going to execute the code in it. So we'll do class main comp. It'll inherit from bge.types.kx Python component. And then we got to create an args variable that'll just be empty set. Then we're going to do def start. With a pass for now, and a def update with a pass. So Python components in UPBGE require you have an args, a start, and an update. And the other one is, obviously I've discussed it before, is dispose, which is the other function. And that's to run code when an object is destroyed in game. And so that code runs when the object it's attached to is gone. And actually, it's when this component dies. You can't actually delete components in games because components are an interface. They're basically like an interface class between the blend file and the game runtime. So you can't really destroy them in game, but when the object is destroyed, this code executes. So that's fine. The components kind of become read-only, right? So once the game starts. Next. So we got that, so we need to attach it to our go ahead and launch script here. I'll make sure I'm in layout. We're going to go ahead and change our layout here. So I'm going to make properties go all the way up to the top. And we're going to drag, when you go to the bottom, drag out a little bit of UI here. Change this to outliner. Where are you, outliner? I know all the people at home already see it. Right there. Okay. And then we're going to change the animation timeline to text editor so we can import script. Click on open. We'll go to tutorial 19 and up a level, go to 19/1. Select our types experiment, Py file, open. Well, I haven't saved it yet, so I got to save it here. There. Then we could do an alt reload, and we'll do a text save so it links with once you save the text in Python, I think it gets instanced inside the blend file. Like some things have changed with Actually, I don't think that's happened in 5.0, but in the 5.2 beta or alpha, looks like a lot more stuff is imported into the blend file. So um, we'll see what kind of errors I end up dealing with when they finally make a stable release, but that's beside the point. All right, next. So we got it connected. We got it. We got the script imported. We got it reloaded. So we're gonna turn this into a ground plane. So we're gonna squash it, and then we're squash it some more, and then we're gonna scale it out, and then we'll go ahead and do kind of a 2D view, and then we're gonna go to object. We're gonna go to view, align active camera to view. Then we'll zoom out a little bit by doing G and Z twice, and then we can pull out. Okay, that's fine. We can go to render view. We'll adjust our lighting. I'll go ahead and turn it into a sun. It's going to be really bright though at 1000. So then we're going to change that to 10. 10 is still way too bright. We'll do 3. And we'll change the angle on it to be like that. Okay. Then we're going to go ahead and put our cursor here. Then we'll go to view 1, and then we'll move it up here. Go back to 0, and then we'll do Shift A, add a cube. We'll add a shader to this cube. And then we're going to go ahead and make it green for player because player's good. I'll try an aqua color. All right, so we got our player collider. We're going to go ahead and scale it down a bit so we have some room to move on this shelf here. And we'll change its physics to character under physics, character. And if we press play, there we go. All right, that's all good. You hit P for play to run it inside the UI, inside the GUI. All right, we're off to a slow start, but that's all right. So now we're actually going to get into this good stuff. So what we want to do is we want to make a bunch of functions we're going to use for different objects. So we're going to go and duplicate this cube. Let's do it 3 times. So Shift D to duplicate, we'll move it over. Shift D to duplicate, move it over. We're going to select the object. I got to get out of cursor mode and select the selection mode up here. And then we're going to go to the materials, and I'm going to click this little number here next to the material name to change it from instance material data. Because right now, if I change this color, all the boxes are going to change. So what we're going to do is click this number here to make the data its own, basically like its own struct. It's tied to the object and not instance data of the material to every object. So there we go. And then we'll do blue, and this one we'll do more of a yellow. Oh, that one. Okay, that one's more yellow. Sorry. Let's do that one blue. And this one, we'll do more yellow, green. Oh, you still got to uninstance the. Click that number, and we'll change it there. All right, good. And if we press play, there we go. They'll drop because they'll have character physics. Normally when using global functions in a script that you're going to be applying to all objects, it might be a good idea to make sure that all their physics types are the same. So the two kind that maintain their orientation, unless you change it, are dynamic and character. And then if you want rigid body physics, that has its own set of different methods and stuff. So you'd want to separate either in the comments of something your global functions, depending on the physics type. But what we're going to do is going to be universal to these three that have character physics. So, all right. So what we want to do is, since these are all characters, they all have the ability to do. We'll have the ability to get their character physics class out of them, and then we have the ability to make them jump. So to do a global function in a Python component, we put it at the top of the script outside the class. So, example, if we wanted to make, let's make them all jump, right? So we'll create a function at the top called def object jump. And since it's outside the class, we don't use self as an argument, so it won't recurse on itself. Then we're going to do so it needs to take in an argument though. So our first argument is going to be the object that we're going to import. And then this is where we use type inferencing. So to do type inferencing, after your argument in a function, you do colon, and then you say what the type is. So our type is going to be BGE types dot kx game object. Okay. Now, when we do this, right, if we go ahead and start writing stuff, right, we could say, actually, let's give this a better name. Let's call it GMOBG for game object, but it's not object because we don't confuse anything, right? So now in this function, if I type GMOBJ and I hit dot, you'll see in my auto completion, it has everything we can apply to an object. We got collision, we got gravity, right? We could change the gravity on it, right? And we even got jump, right? Nope. So what we have to do is actually import the physics. So we're going to create a variable called obj physics, and that'll be equal to gmob. That'll be equal to bge.constraints dot get character, because we're getting character physics, right? If we go over here and look at their physics, it says character here, right? So we're doing get character. So that'll give us all the physics, and then we're going to change the name of the argument to GMOBJ. Okay. Now this allows us to basically do all the physics methods on the character physics for an object. So next what we can do is go obj.phys, and then what we'll do is we'll create an if statement. So if objfizz dot it should work. Okay, so if objfizz dot on ground, there we go. We'll do obj.physics jump. Okay. So we've basically created a global function here that accepts a kx game object type. It gets the variable here, gets the physics using the constraints class getCharacter function from the argument in the function. And then on that variable, we can call the jump method. And now if we go into our main comp here and we say, we can now call this function. So now we can, in update, we do object jump. And then the object we need, it tells us the type. And so our kx game object is going to be self.object. And to prove that self.object, the object we attach the script to, is a kx game object, we can also print the type. So we can go print type of, or print type, and then self.object. There you go. So we'll go ahead and add, we'll make the middle guy jump first. So I'll click on the middle guy, go to our Python tab in the properties here, right there. And we'll go to add, and then we have to add we type in types underscore ex from our Python file name. And then we do dot, then our class name, which is main. So we'll do main, or just main comp. There we go. That imported, it's connected to the object. And now if we go ahead and press play, it's not jumping. Why is that? Let's find out. We didn't get any errors, so. It also didn't print, so that makes me think there was an error here. Okay. Oh, we have to reload the component. Oh, I have to save the component first. There we go. All right, and now if we make it jump, now if we press play, look, our little guy in the middle is so happy he's jumping. And we see down here that the class of the object attached to the script is the kx game object. So now let's go ahead and get out of the engine. Yep. And then I can attach this script again. Attach this component. Now if I press play again, they're all jumping, right? Even though we didn't have to name the object or bring it in or point to anything. See, we're able to save a lot of code by creating a global function that accepts the type reference, right? Now, if we want to do properly formatted Python code, we also want to do the return type of the function so that the documentation, someone can see knows what it outputs, right? So there are different ways we can handle this, right? If we wanted this in addition for this object jump to apply, let's say we wanted to, we could say, no, we don't want to do that. That's bad form. Okay, never mind. So what we can do though is set the return type. So if I do this arrow operator, right, it's a dash and a greater than symbol, right? If I do return type none, now someone looking at this knows that the output is going to be nothing. It's basically like in C# or in Java, right? It's like void, or in C++, it's letting you know the return type is going to be void, right? So output none is the same. Return type none is the same. So, and what that does is the Python, it's soon going to be a just-in-time compiler, but for now it's still the interpreter. The Python interpreter basically um, says, if you try to do something weird, it'll say, hey, the output of this is supposed to be none. You can't do that, right? So it helps with debugging. It makes you write cleaner code. So, well, not clean code. I don't care about clean code. I care about productive code. But yeah, so you want to do return types. So we can do that. And then, for example, I'll just show you this as an example. So if I change this return type to bool, right, instead of none, and then I say if on ground, return fault, yeah, return false, right? And then here I can do else return true, right? And if we've done that, then our type inferencing says we're taking in a BGE game object. Our output's going to be a bool, and this other stuff is going to happen. This is what we call mutating code. This is actually bad form, but I'm doing it to show a point here. So what we can do though now is this object jump can be used in an if statement, right? So now we can use it to check if the object is jumping in addition to make it jumping. So you can do if object jump, then print jumping. So what this will do basically now is when the object jumps, it's going to return this bool. And in the if statement, when the bool is true, it'll print jumping. So when it's true is when it's on the ground. So it's going to be jumping once it's on the ground. When it's in the air, we could say else print falling with style. There you go. And now if I do that, it's going to execute this code in the if statement every time it's on the ground. And when it's not, it's going to just print this out. So if we try this now, it should jump, but then it's also going to start printing in the console that text. So we'll take a look here. So we'll play it. Yeah, see. So it says jumping, falling with style, jumping, falling with style, jumping, falling with style. So that's how you use return types to do stuff. So, right, these are what we call side effects, right? And sometimes you want side effects to create certain behavior. It's just another way of thinking about code. But normally, my process is anything that makes the object move or do something that's going to be a return a none. So it's a void output. because it's just affecting what's happening in the game and not returning a value we're going to use for anything else. So usually I'll do our type output is none. But then if I need to feed other data into this function, right, I'll have an additional argument like I do from enum import enum as en, right? And then what I can do here is we can add an input to this jump function that's enum by just going we could call this jump state and then do its type that it takes in as en, right? So basically we're using type inferencing. So this function can take in two arguments now. It can take in the game object it's applying stuff to, and then a jump state called enum. And it's going to return none, right? But that's just an example. So we'll undo that. Okay. So what's some other things we can do? So now that this KX game object is able to jump, we'll get rid of this return typing stuff. What other things do we want to do to this? We could shift the color of the material. We could do that. So what we'll do is on each of these, let's bring up the shading tab. So we'll select an object, go to the shading tab. And then go ahead and add an RGB tab. Oh wait, we got the values here. We could just change let's see what we got. It just says hue. Oh, my Python tooltip's not enabled. That'd be weird. Oh, Python tooltips are enabled. That's interesting. Okay. Okay, we need to go ahead and add an RGB node to an RBG node and a hue saturation. So do Shift A, search for RGB. Color. Color ramp gamma invert color mix color RGB curves combine color. They got rid of the RGB. Well, let's just look up color here. Oh, just color. Okay. Used to be able to do an RGB node. That's strange. That change in 5 point? No. I've used it before. Let's find it. Color. That's weird. I'm gonna have to look for it. Give me a sec. All right, I think I know how I'm going to do this. This is going to make the people on the Discord happy because it's what they do all the time. So I'll go ahead and do it too. So I'll do Shift A. We'll do object info. So we'll plug the color into add hue and saturation. Forget that. We'll just do it here. Oh, we can't do it there. Okay. Oh, that's what they did. They had the RGB section too. Okay, fine. Okay, I'm adding hue and saturation in each of these. There used to be just a node called RBG, and I don't know where it went. I didn't think it disappeared in 5.0, but oh well. Or maybe I just don't know the name of it. Okay, you're going to be Aqua. And then we're using the hue and saturation node here, and then this will be more blue. Okay. Look at the layout, see how it looks. Yep, that looks great. Okay. So what we're going to do is we're going to create a KX game object global function that's going to basically up the hue and saturation, up the hue. So these things like cycle through the color wheel. And so what we'll do next is go to, I'm going to get started coding. So the next global function will be created is called OBJ hue shift. And it's going to take in that same thing, GM object. Now, when you're doing a function that's going to apply to all objects in a scene that have the component attached, it's important that the shader has the shader nodes have the same name of what you want to change with the code. So like if we go back to shading tab, you'll see they have hue saturation value, right? And hue saturation value. Right, so they all have the same node that has the same thing. So this code will be able to apply to changing this shader node because it has the same name as what we're going to be using. So, all right. So next, what we're going to do next is we need to import the shader. So we have to create a variable. We could call it hue node because that's all we're going to be changing. And we'll do hue node is equal to GMOBJ dot blender object dot active material dot node tree dot nodes. So this section of code here, right? Blender object active material node tree nodes. That's basically this section of the window here with the nodes in it. And then the node tree is like the entire instance, I think, of the environment. And then the nodes is the nodes inside this panel here. So nodes, and then we gotta get the name of this node, its actual name in Python. So we just highlight over a property here. And it says its name is a string called hue slash saturation slash value. So now we do quotations for our string and hue slash saturation slash value. Okay. And then we're going to basically the rule for updating a variable with the property you want to change is you want to go to the farthest bracket. So if you look here under the description, I wish I could zoom in the drop down text more, but basically the last set of brackets is for dot input 0. So I'll show you up here, and let me make this bigger. So this will be dot inputs 0. So this dot input 0 represents this hue section here, right? Of hue saturation inside the node tree, right? And see, we haven't chosen our object yet, right? But we know that all the objects we want to do it to have the same node in it. So we can do this, right? So next, so we're using the type referencing, right? So we can get access to the methods that we want to use as if we had already assigned the object to a variable, right? And what this means is anywhere, if I make a really long game and anytime I want to hue shift the colors, I just have to, on an object, I just have to use this function. And I don't have to retype it again, right? So it's something called dry, D-R-Y, do not repeat yourself, right? So it's the only programming convention that's probably worth anything, according to some people. So, you know, make your code work. Don't care what it looks like. All right, next is hue node. Okay, so we got that. So then the method the value we need to change is listed in the description here in the tooltip. It's called default value. So now to do our hue shift of the object, we have to do hue underscore node from our variable and then do dot. Now autocomplete won't work because the Python tooltips are not in what we call the BGE stub file. The Python stub file is what creates the autocomplete, right? So you just have to reference your Python tooltip. So we know it's called default value. And then what we'll do is we'll do kind of a slow burn. So we'll do plus equals 0.001. Now, what's the max value of our hue here? The max value of our hue shift is 1.0. So basically we want to do if hue node dot default value is greater than or equal to 1.0, then we'll set hue underscore node dot value dot default value equal to 0.00, or just 0.0. All right. So what this does is it keeps our output afloat, right? But also, so basically, once this thing hits max, we're going to set it back down to 0, the minimum. So the minimum hue shift is 0. The max is 1.0 because it's normalized. And so, and then the reason we do greater than or equal to is sometimes the logic tick might be faster than the update in the environment. And so you could end up with an error if it goes into 1.1 or something like that. So this kind of negates it. If it goes greater than 1, it makes it 0 also. Because if you do equals, it has to exactly equal 1.0. And sometimes, the logic tick can be too fast for that. So, all right. So we got that. And then in our, we're getting rid of this if object, right? We don't need to do that anymore. We just need to execute the code. And we'll get rid of the X. We'll do, yeah, there you go. And then next we'll do hue object, hue shift object. And you see how short and concise it makes the code to do this, right? We're creating one function, we're calling one function. There's not a lot of, So this is a very tight way of programming, I guess. So I'm glad I did this tutorial because I might be using this in the future. So yeah, so we're type inferencing. So now if I go ahead and save this code, get back to my text editor, so get back to layout mode, reload our script, and then run it, you should all start cycling through like a rainbow. No, not yet. And did we get an error? Oh, wait, it is happening. Okay. This is very slow. Cool. So it's working. We'll go ahead and apply that script to this guy. Play it. We see their colors are cycling through the color wheel. It's really subtle, actually, at that speed. That's good for an effect, maybe. Some of those TikTok videos or some crap. All right, so we've done that. So let's speed up the effect now. So we'll do 0.1, 0.01, and that'll cycle through more rapidly. There we go. That's obvious. All right. So other ways you could do this is you could create like a move left and move right, right? So we'll go ahead and create a time variable in our component, right? So we'll do self.timer is equal to 0.0. And then down here we'll do self.timer is equal to, and we learned this from our last tutorial, that basically at 60 frames per second, our logic tick interval being 60, right? To increase time, we can do it by type, increment it up by 0.01666667, right? So, or 6, we'll just do 6. Okay. Don't want our timer to gradually gain speed. So, all right. We're linearly gain speed. Next, the next what we'll do is we could do 3 seconds, or let's say we'll make these objects move left for 2 seconds, right for 2 seconds, something like that. So we'll say If self dot timer is greater than 2 is greater than or equal to 2.0 and we'll go ahead and create a function, two functions called move left and move right. So we'll do def obj move left and def obj move right. Then we'll do def obj stop. Putting passing these for now. Save it. All right. So what we want to do now is we go ahead and create a argument in this function. It could be anything you want. We could call it Billy, but we're going to call it GM object. And then the type we're inferencing is BGE.types .kx game object. And all this is going to do is do GM object dot world position dot x and it'll be and we'll go ahead and add a speed variable here too, a speed argument. So then we'll do comma move speed, and that'll be a type float. And its output is going to be again to none. There you go. Okay, so we had our move speed argument. So down here, we're going to add a global variable called speed, self.speed, and we'll set it equal to, we don't want to move a lot because we don't have a lot of space on this platform we created. So we'll do dot 02. And then we'll do, so what we're going to do in this function here is we'll do move speed float, gm ob dot world position dot x. So we're moving left, so it'll be minus equal move speed. And then I'm going to go ahead and delete this function here. And then we'll yank it, and then we'll paste it, and change this to object move right. And then this will be plus equal speed, move speed. Since they're moving back and forth, we don't need an object stop. So we'll do that. And now we'll do if timer is So we'll do it from range 0. So if 0.0 is less than self.timer and less than 2.0, self dot, no, we don't need to do a self, we just need to do object move left, then self dot object, and then self dot speed. And then we'll do elif 2.1, or oh yeah, we could do 2.0 is greater than, oh no, if self.timer if 2.0 is less than self.timer, there we go, and less than 4.0, object move right, self.object, self.speed. Then our else statement will be, so basically once this timer is greater, once this timer is greater than 4.0, it'll change the timer back to 0.0. All right. Oh. There we go. So now when we do this, they should be moving left and right as they jump and changing color. So we've done a lot, right? We've created 4 functions. We've executed them with some ifs, and it's only 40 lines of code, right? And but it's doing it to 3 different objects. We don't have to worry about importing all these different objects. We're just using a function that uses the type reference of BGE types.kxGameLogic. So all right, we'll play it and we'll see how it goes. Hey, look at that. They're happy and they're dancing. Isn't that great? So we basically created some AI behavior, right? By using type referencing, limiting the number of, putting our functions at the top outside of class so they could be referenced by every other component. So this is, right, this is like software architecture, right? We're trying to architect what kind of things we don't want to repeat that every object is going to use in our game, right? And this can save us a lot of time. So it might be a good practice, right, to create functions at the top of your script that reference the BGE types KX game object, right? And then the data types you want to bring in. And then only use the components to execute those functions, right? And so your code can be more efficient, so to speak, right? The other cool thing about this, though, is that if you decide to put these functions into another Python file and then import it and then reference these, right, you could actually increase the performance because once BGE imports a class, right, it caches it to a folder, and it's instance inside Python until until the engine closes again. So you could find, some FPS performance by doing this too, but that's for another tutorial. So let's go over the script and then we'll call it good. So yeah, so first we created a object jump function with a argument of, you could call it Billy, call it Bob, call it Robert, you could call it Ragnar, but we called it GM underscore OBJ. And then we use the colon to type reference from BGE.types. And you can do this with any type inside of BGE because, right, type referencing means it's a type. And so BGE types.kx game logic. And what that does is any variable in the function now gives you access to the abilities of a KX game object. And then we did the same thing here for HueShift. We did HueShift, KX game object, and then we used all the methods that would be on an object in the game. But we didn't create the object yet, right? We didn't have to bring it in as a variable. All we did was create a function, and then we can use that function on self.object. So all you have to do now is attach the script to a bunch of different objects, and they can all do it. Like, here, let's bring in a sphere, right? Mesh, let's bring in a UV sphere. Where are you? Oh, I didn't. Oh, okay, fine. Oh, is it down here? Yeah, it is. Okay, we'll bring them up. Okay, and then we got to give them material real quick and make them colorful. And then quickly add a hue and saturation node and attach it. Get back to layout, and then we'll make him big and have him dance in the background, right? We'll think of some kind of cool compositional design, right? And we'll smooth him out so he's a ball. There you go. All right. And then go back to shading and change this color to purple. There you go. And then if I just attach the script to it real quick. Let's get it a little bigger here. Go back to layout. Okay. And now, oh, we didn't do it. Oh, I gotta set his character physics first. So, physics, set it to character. And now when we do it, look, they're all dancing together. Isn't that great? Now let's make it more compositionally cool. All right. So yeah, so that's how you use global functions with type referencing to basically pre-program your behavior and then just using a component to execute that behavior. So just remember that, yeah, if you do a type reference in your arguments of your functions, inside the function, it'll give you all the abilities as if you're using an object. All right, so yeah, have fun playing with your objects, playing with your squares and your balls, and have a great day. Bye. Shake, 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 senora, shake your body line. Shake, 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 senora, shake it all the time. Work, 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 senora, work your body line. Work, work, work.